Hello, and welcome to this West Features video that demonstrates the use of the new Simulation Mass Balance tool, which has been introduced in West 2025 Update 1. This tool can be used to generate a snapshot of the mass flows of all state components, plus a set of conventional aggregated components, such as COD and TSS, for each terminal of the West process layout at the end of any simulation. After you have run a simulation in West, you can click the Simulation Mass Balance button in the project menu to generate a mass balance output file. You can specify the file name and destination folder in the Save Simulation Mass Balance dialog, and then save the results as a text file. You can then open the text file in Excel to view and analyze the results. The output is saved in comma-separated value or CSV format, so when you open the file in Excel, you need to set comma as a delimiter in the text import wizard. The output file contains the state component vectors for the main category, in this case ASM1. We have the standard ASM1 components, as well as the non-standard aggregate components, BOD, COD, total nitrogen, total phosphorus, and total suspended solids. Each column is the mass vector in grams per day for a specific terminal, with the name of the terminal's model block currently listed in alphabetical order, followed by the block it is connected to, listed in the second row. There are also secondary state components for other categories, in this case ADM1, listed under coupled models. In this project, the anaerobic digester is a coupled model consisting of an ASM-ADM transformer connected to an anaerobic tank connected to an ADM to ASM transformer. We have the gas flow component vector, inflow and outflow vectors in ADM components, and transformer inflows and outflows in ASM1 components. This allows us to calculate the mass balance over any unit or node in the plant layout. For example, we can add a calculation of the COD and TSS split between the effluent and sludge from the primary clarifier. These results are for the default non-settleable fraction, or FNS parameter, of 0.6. We can rerun the simulation at a different value of the parameter, say 0.35, generate a new mass balance output file, copy the calculations to the new spreadsheet, and compare the results.